today so that you get it. All right. So we're going to start with number 5 here. Block rests on a surface. Second block sits on top of the first. Horizontal force F applied to the bottom pulls both blocks at a constant velocity. Here, M1 equals M2 equals M. All right. So we need to do the force diagram of the total system and of each individual block. And if it's moving at a constant velocity, what does it mean the acceleration is? Zero. Well, because remember, acceleration describes the change in velocity, so it's constant. So that means there must be another force resisting the motion. Otherwise, this force would cause acceleration. So I know right away that there's friction there. So this is, let's see, number 5, right? So I'm going to have 3 force diagrams. I'm going to have the one for the system. I'm going to have the one for the lower block. And I'm going to have one for the higher block. Like that. So I'm pulling with the force F this way on the Earth, so it has a weight down. I'm calling it total weight. Something we haven't been doing, but something that's not a bad idea, is to write the inertia right in the force diagram. And in this case, they tell us the inertia of each block is M. So the inertia of the system would be 2M. I'm going to have a total normal force up, and I'm going to have a frictional force total in that direction. And that would be the correct force diagram for the system. It would get me about 1/3 of the points for this section. So I need to do the other 2. On the bottom one here, I have that force F. I have this frictional force total. I have the weight of the block. We'll call that just Fg. I have, let's see, I'd have a normal force. I'm going to call that force normal 1. Let's see. Oh, if this block is sitting on it, that means it's pushing down. So I would have a force downwards on this one equal to Fg of block 2. Oh, because this one would have a weight down of Fg2, a normal force up of Fn2, right? Now, this is moving at a constant velocity. So that means it's not accelerating, so that means there's no total or net force horizontally on it. So there's no, I think I'm done. I think I'm good. Yeah, there we go. All right, so those would be, and oh, whoops, maybe I should label this have inertia of M and have an inertia of M. And now let's see, what do they want to know? I got those all done. They want to know what is the normal force exerted by the surface on the bottom block. So that would be the normal force exerted by the surface on the bottom block would be my Fn1. Right? So so the free body, the force diagram I need to use is the bottom block there. And what I need to do, I only have my one equation, so I'm going to start my how. I only have my one equation. Sum of the forces equals MA. to draw the free body diagram for that block as a way to write that equation, but write it as a picture. So pictorially, got start there. Label it M. See, it's going to have FG1 down, FG2 down, friction force total here, F here, and F and 1 upwards. I think that's everything. Yep. So since the force that I'm interested in is in the y direction, do you guys need me to redraw this as in x and y? Or can you see x and y? FF total. So you guys can see x and y okay? So I've taken some of my forces and I've just drawn it rather than write in the math in math form. I've written it, I've drawn it. Now I'm going to do in the y direction and write it in math form, which is the exact same thing, Fn1 minus Fg2 minus Fg1 equals my mass m times my acceleration 0. Also, Fn1 equals Fg2 plus Fg1. Right? Yes? No? Let's see, G2, Fg2, that's the weight, so that would be mg. So that would be mg. Fg1 also has the weight of mg. Also, it'd be 2mg. Which one? That's an M. See, I just would follow me vertically down. So really, that's why the free body diagrams are part of your house, because they're just, this diagram is the exact same as this equation. It's just a different way to picture it. Drawing versus writing out math terms. Okay? And let's see, then the next part they wanted was the normal force exerted by the bottom block on M2. So that would be Fn2. And so you would do your free body of the top block, put it into the equation just like we just did for this block, and you'd find Fn2. So same exact procedure, just for the top block rather than the bottom block. And then, these last two are just if, you know, if not all the masses are the same. So that really changes makes the inertia here 3, and so that changes, if I change the amount of mass it has, it changes the inertia, which is okay because it's not accelerating, but it also changes the weight. So it makes those weights different. That would affect it. Alright? Good. I think the really big part for you to see is realize that drawing that free body is exactly the same as writing out the mass terms. They're both just expressions of Newton's second law there. Alright? Alright, so we're going to do number 4. Miss Alex was asked to move 2 boxes, blah, 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 frictionless floor. Oh, sorry, it's the other Alex. So I smooth it at the same time by pushing on the box A with horizontal this, and this. So they want to know the acceleration of the system, the force exerted on the smaller one by the larger one, and what if you pushed from the other direction instead? Alright? So, number 4. How many force diagrams do I need? 3. How do you know 3? System, and then there's 2 bodies, 2 boxes in the system. Excellent. So here's my system. And then I have the large box and the small box. And let's see, I think I'll write my masses right in them. The system has a mass of 21, mine is 21.9. This one is 7. And this is 14.9. Alright, let's see. F, force, normal, total, F sub G, total, acceleration, they're all going to be accelerating together. The weight of A, the weight of B, force normal B, force normal A, F, let's see, the 14.9 is going to push on the smaller one, so we'll call that F1. And if the 14.9 pushes on the smaller one, what does the smaller one do to the larger one? Pushes back on it. Everyone get that? How do the size of those 2 forces compare? Same. So they're both F1. Alright? So those would be your correct force diagrams for Monday. And let's see, I want to find out the acceleration. So I'm going to use the system to find out the acceleration. So first thing I do is write my equation, as always. And I'm going to plug into my equation 21.9 kilograms. F FG total, normal total, acceleration. So there I've plugged into my equation, right? Do I care about the x or the y direction? The x direction. So let's see, I only have one force to put in mathematically. 21.9 kilograms. And then A. And I think they tell me F, don't they? F is 9.2 for me. So rather than F, I know this equals 9.2 newtons. I'm putting 9.2 newtons. And then solve for A. That was pretty straightforward. Now they want me to find force F. F1. And, so I think I'll use the small box to do it. Start with my, do I need to do this or you guys got it? Sorry, keep going? Okay. So, start with my equation. Fill it in pictorially. 7 kilograms. How big it is? Let's see. It has the force on it in this direction that we called F1. It's got FGB. Force normal B. And it's accelerating in that direction. That's right, isn't it? Yeah. And so now writing that same thing, but in mass symbols, I get F1 equals the mass, which is 7 kilograms, times the acceleration, which is whatever I figured out up here. And I can find out what F1 is. Yes? Now, the last part they ask you for, if Alex were to push on the other side of the 7 kilogram box, on the other side, on the 7 kilogram box, how would your answer in part B change? Well, the acceleration's not going to change, but the force between them is going to change. And so really, for this next part, we should draw new diagrams and it's going to accelerate in the other direction now. .2. Guys, remember, if you don't need this problem, don't feel you have to follow along, but please be quiet enough so I can hear myself think. And so those would be the correct ones for the second part. And then I would use the 14.9 kilogram one, knowing my acceleration is the same, to find out what F2 is. I would use the 14.9 kilogram box, knowing that the acceleration is the same as the first part, to find the F2. You got it.